Okay, today we discussed the final of the three trig ratios, main ratios, the cosine ratio. So we read a little bit about here what a guy wire is. A guy wire is a wire that's attached to some tower or pole to provide stability. And so that's often the setup for some of these right triangle trig problems. So you need to kind of read that and understand how we would draw this particular situation. We've got a couple of models here. I want to label this drawing that they've given to me based on the scenario here. It says the guy wires are attached to the tower 400 feet from the ground. So the wires are attached 400 feet from the ground. That means this segment here is 400 feet, the vertical segment. Then it says also the guy wires are attached to the ground 300 feet from the base of the tower. So I'm on the ground and I'm going from the base of the tower. So this segment is worth 300 feet. Then it tells me the angle the wire makes with the ground is 53 degrees. The wire making an angle with the ground. That's this angle right here. This is 53 degrees. And then finally it tells me the length of the wire is 500 feet. So that's this piece here. If we just drew this triangle out of the scenario here, it would look like this. 400, 500, 300, and there's our 53 degrees. And for this drawing, we need to, for the reference angle, draw or create the ratio of the side adjacent over the hypotenuse. So this ratio would be 300 feet to 500 feet. I'm not going to write the feet because the feet will divide out to 1. And I could simplify this if I wanted and just write it as 3 to 5. Going on to the second scenario. It says guy wires are attached to the ground 355 feet from the base of the tower. So I've got ground. So I know I'm here, and I'm talking about this segment here, 335 feet from the base of the tower attached to the ground. The angle the wire makes with the ground is 48 degrees. So this angle here is 48 degrees. The length of each guy wire is 500 feet. The wire is 500 feet long. And finally, the wire is fastened to the tower up here, which is 371 feet from the ground. And if we were to just draw the triangle representing the situation, here's the right angle, the pole being or tower being perpendicular to the ground. Here's our 335 feet, our 500 feet of wire, our 371 feet attached on the tower, and our angle of 48 degrees. Again, using 48 as our reference angle, if we make a ratio of the side adjacent to the hypotenuse, we will get this ratio. And the ratio that we just created has that special name called the cosine ratio. So from this point forward, we're going to write the cosine of our reference angle gives us the ratio. Just like this example here. The cosine of our reference angle A is the length of the side adjacent, that's the side that is not the hypotenuse but makes the angle, over the hypotenuse. So for the triangles below, we're going to write the cosine ratio. Again, it's got a name, so now we've got to use that in the ratio that we write. So So I like to circle the reference angle and the things that I need. I need the side adjacent and the hypotenuse. And I write the cosine of 21 degrees is the side adjacent over the hypotenuse. Circle the things I need, the reference angle, the side adjacent, and the hypotenuse. The cosine of the reference angle of 48 degrees is the side adjacent over the hypotenuse. Find the reference angle, the side adjacent, and the hypotenuse. We say the cosine of our reference angle of 53 degrees is the side adjacent over the hypotenuse. And my reference angle, the adjacent side, to write the cosine of 60 degrees is the side adjacent over the hypotenuse. And then we could get our calculator and calculate the unit rate if we'd like, so that we can see how the secant is, or how the cosine is behaving. I take 50.4 divided by 54 and I get 0.93. I take 335 and divide it by 500 and I get 0.67. I take 3 divided by 5, I get 0.60. And I take 25 divided by 50. Oh, I could do that one in my head. This is 0.50. So, as the acute reference angle gets larger, so I'm looking 21 to 48 to 53 to 60, what is happening to the cosine ratio? It is not getting larger. This one behaves differently than the other two that we've seen. The cosine ratio decreases. And then here we're just going to get our calculator and calculate the cosine of these various angles. So you find the button that looks like this. You hit it and you type in your 30 right after the word cosine. And you get that this is 0.87. The cosine of 45 is 0.71, rounding to the hundredths. The cosine of 60 is 0.5. We had that one here. And the cosine of 90 degrees something interesting happens here. We get a 0. Now, like for our other ratios, now the other ones had the co with them. They had the sine had the cosecant, the tangent had the cotangent, the cosine has the secant. So if we kind of just review, cotangent and tangent are related. The sine function and the cosecant function are related. And then the cosine and the secant function are related. And I guess we have to just remember that the S and the C kind of switch places with these two. It would have been nice to have them both have the S's, but that's not how it works. So the secant of a reference angle is the reciprocal of the cosine. So rather than being adjacent over hypotenuse, we see that it's the length of the hypotenuse over the side adjacent. Or we could just take the reciprocal of the cosine function. Right, so what we're going to do now is practice writing the secant ratio, and then we can calculate that. So again, we're going to need those same components that we needed for the sine ratio, but just in the opposite order. So I have secant of 21 degrees is the hypotenuse over the side adjacent. The secant of 48 degrees is the length of the side of the hypotenuse over the length of the side adjacent. The secant of 53 is the length of the hypotenuse over the adjacent side. The secant of 60 degrees is the hypotenuse over the length of the side adjacent. And we could calculate these ratios getting our calculator. So this time we're dividing 54 by 50.4 to get 1.07. We can divide 500 by 335, and I get 1.49. I take 5 divided by 3, 1.67, and I take 50 divided by 2, don't need a calculator for that, and I get 2.00. And actually this should say secant, sorry about that. What happens to the secant ratio as the acute angle gets larger, our reference angle? Well, we can see it's getting larger from left to right, and our secant ratio also gets larger. Secant ratio also gets larger. Okay, and then to find the secant of an angle, there's two things we can do. We can take 1 and divide it by the sine of that angle, or you can find the sine and then use that reciprocal button. Please again, make sure your calculator is in degree mode. If you're getting negatives, you know that that's not the case. So please check, verify. Ooh, this one's a little interesting. You might get something about an error when you type this in your calculator. This one does not exist, and if we go back and we think about what the sine of cosine of 90 degrees is, it's 0, so I'd have 1 over 0, and division by 0 is undefined. All right, last little bit of the lesson, talking about the inverse cosine or arc cosine function. This is the one we need to use when we need to determine the measure of a reference angle. So it says that if we know the cosine ratio for an angle, then we can figure out the angle's measure by using the arc cosine or the inverse cosine function. And so it says if we have a cosine ratio for angle A that's 2 over 7, then we can calculate the measure of angle A by using the inverse cosine function. And so you look for your cosine button on your calculator, and you might have to press like second or shift to get, because above that is probably something that looks like this. So you have to get that second or shift button to get that inverse cosine function. Okay, and so now we're going to go ahead and use the cosine ratio, writing it, and then solving our equation for the measure of angle B. So we find our reference angle, we need adjacent and hypotenuse. So I say the cosine of angle B is the side adjacent over the hypotenuse. Since I need to solve for B, I need the arc cosine function. And now I get my calculator, and I have the measure of angle B is 27.27 degrees. I'm rounding to the nearest hundredth. That's 2 decimal places. And I find my reference angle of angle B, and I write the cosine ratio for my reference angle B is the side adjacent over the hypotenuse. I want the measure of angle B, so B then is the arc cosine or inverse cosine of 5/8. Then I get my calculator to determine the measure of angle B is 51.32 degrees. A couple problems just to finish off the lesson. All we're doing is writing the cosine ratio. We find the reference angle, the adjacent side, and the hypotenuse, and all we have to write is the cosine of angle A is the side adjacent over the hypotenuse. If this was able to be reduced, we would reduce the ratio. Writing the secant ratio, I need the same components, but the reciprocal. So the secant of angle A is 37 over 12. Now we need to find the measure of angle A. So we go back to our equation that we wrote. The cosine of A is this ratio of the side adjacent over the hypotenuse, which means angle A is found by using the arc cosine function on this ratio. And we find, once we get our calculator, that the measure of angle A is 71.08 degrees. The last one here, we're going to use the cosine ratio to find the missing length. So this time I'm not going to write cosine of E because I know what the reference angle measures. So I write the cosine of 40 degrees is my side adjacent over the hypotenuse. Solve for x. X is 8 cosines of 40, which means x is 6.13. Makes sense because it has to be some value smaller than 8. 8 has to be the largest side of the right triangle.